common collector configuration circuit. Now, common collector is also called emitter follower configuration circuit as well. So common collector and emitter follower is one and the same thing. The point is that the common collector has got the output characteristic curve similar to the one which we have seen for the common emitter configuration circuit, and therefore the common collector configuration circuit is also called the emitter follower configuration circuit, because the output characteristic curve, they are exactly similar to the one which we have done for the common emitter configuration circuit. So therefore common collector configuration circuit, they are normally called the emitter follower configuration circuit. And as the name shows that the common collector, they are having the collector which is common in between the input and the output side of the configuration circuit, right? So if you take a look, this means that the collector is going to be common in between input and the output side of the configuration circuit. So the rest is the same thing which we have done in case of common emitter configuration circuit. So it's exactly the same analysis is going to be for the emitter follower configuration circuit. So let's move forward, and when we go ahead, so what we have basically the next chapter, which is chapter number 4. And in chapter number 4, what we are going to do, we are going to take a look of the various circuits for the DC, analysis, right? Or this is also called the DC biasing. So what we are going to looking for, we will be actually looking for the DC analysis of various circuits, right? Now, the first circuit which we are going to take a look is called the fixed bias configuration circuit. Fixed bias configuration circuit. Now, in fixed bias configuration circuit, what we have, if you see, we have a circuit in which we have transistor, as you know, we have the base, we have the emitter, and we have the collector of the transistor. With that, we have something in the collector, the resistor, which is the RC. We have also another resistor in the base of the circuit as RB, and they are being connected with a DC source as VCC. Can you see it?
No, sir.
सर आपका स्क्रीन हैंग है।
No, sir.
Okay, just hold on. Now you can see it?
Yes, sir.
Yes.
Yes.
Okay. Okay, with that, what we have the circuit which has got the input signal that can be given over here. What we see is the input signal, that can be given over here, as well as we should be able to get the output signal from here, right? And the emitter is directly grounded over here, right? Now, as we have said that we will be doing the DC analysis for this chapter. So to start the DC analysis, the first point is that what we need to do, we are going to look into the DC circuit, because the input signal and the output
सर
signal.
आपकी आवाज कट रही है
Okay,
सही है सर
ठीक है जी.
यस सर ठीक है
So as we have started with the DC analysis, so what we need to do, we need to make this circuit as a DC circuit, right? So first thing what we need to do, because if you can see, we have one capacitor over here which we call C1, which is at the input side C1, and we have another capacitor C2 over here, right? Now for the DC analysis, how the capacitors they need to behave, anybody?
ओपन सर्किट
डीसी ब्लॉक कर देगा
ओपन सर्किट
G, because for the DC analysis, the frequency is, as you know, for DC the frequency is 0, right? When the frequency is 0, and if we want to see what is XC over here, XC is 1 divided by 2 pi FC over here, right? Now when the frequency is 0, so this means XC over here will be equal to infinite, right? Infinite means this will be behaving as an open switch, right? So how we can transform this circuit, that C1 and C2 for DC, they will be behaving as an open switch. So what we can do, we can actually take out C1 and C2 from the circuit. So we will be left with something like this, as well as we can take out this from the circuit. So we are left with this. Are you with me?
नो सर सर ये कैपेसिटर्स हमने क्यों हटा दी
As I have said that we need to do first the DC analysis of the circuit, right? And for doing the DC analysis, what we know that for DC, what is the frequency? The frequency is 0. Are you with me? The frequency is 0 for DC,
जीरो
right?
यस
So when the frequency is 0, so if we want to see what is XC, XC will be equal to 1 over 2 pi FC, or XC will be equal to infinity. So for DC, the capacitors, they will be behaving as a very, very high resistance, right? And a very high resistance, this means if it is infinity, it will be behaving as an open circuit, right? So an open circuit, this means we can simply take out from the circuit over here, as you can see, right? Are you with me now?
यस
Right? So this is the first step, that for DC analysis, we will take out the input side and the output side signals, and because these signals, they were connected from the capacitor C1 and C2, so we are left with we are left with this circuit, right? Now further, as we need to we need to do the DC analysis, and we need to see the the circuit from the input side as well as from the output side. So what we need to do, we need to again modify this circuit further on, and to make it a simplified version of this circuit, what we can do, we can redraw this circuit, and the simplified version can be, if you see, we have the RB over here, we have the RC over here, then we have the transistor. RB is connected to the base of the transistor. This is the collector of the transistor, and this one is the emitter of the transistor, and the emitter of transistor is grounded. As well as, if you see, RC is connected to VCC over here, as well as RB is also connected to VCC. It is the same VCC, but I'm just making it a simplified version. Are you with me?
Yes, sir.
Yes, sir.
Okay, with this, we also know from our previous knowledge that IE is equal to IB plus IC, right?
Yes, sir.
And we also know this thing that IC
Yes, sir.
is equal to beta times IB. IC is equal to beta times IB, right? And we also know this thing that VBE is normally equal to 0.7 volts, right? Are you with me?
Yes, sir.
Yes, sir.
Okay, with this, we also know this thing that for any circuit, there is the input side as well as the output side, right? So from this circuit, if we see that we have a current which is flowing in the base of the circuit as IB over here. The current which is flowing in the collector of the circuit is IC over here, and the current which is flowing in the emitter of the circuit is IE over here, right? With that, we have also the potential between the base and the emitter is VBE, and the potential between the collector and the emitter is VCE over here. Are you with me?
Yes, sir.
Can you hear me?
Yes, sir.
Okay.
Yes, sir.
Okay, so with
No,
this,
sir.
आवाज कट रही है सर, सही आवाज नहीं आ रही।
सर ये VCE किधर से आ गया सर, ये समझाए।
अच्छा जी, any other question?
Sir, the input output signal game capacitor only also, sir.
ये तो वही कहानी हो गई कि आपको जो मैंने पूरी कहानी सुना दी और उसके बाद आप कहते हैं कि जुलेखा मर्द था या औरत थी। हाँ
दुलेखा का जो कैसे है
हाँ
Sir,
और
मैं पता है सर कि
बना
DC
ले
block
सुबह।
तो ये
फिर भी ये लोग बोलेंगे कि वो मर्द था।
ठीक है ना, तो ये इसीलिए कह रहा हूँ कि ये जो नए पूरी कहानी मैंने आपको 3 दफा समझाई, आप फिर पीछे लेके जा रहे हैं मुझे। ओके, let's go back and let's talk about there, right? So why we have taken the capacitors out from here? We have taken the capacitor out because we have started, initially we have said we are going to do the DC analysis, right? Now to do the DC analysis, the first point is in DC the frequency is 0, right? When the frequency is 0, so what we see that the capacitors, they will be behaving as an open circuit, right? When they are behaving as an open circuit, so therefore what we have done that from the capacitor over here and the capacitor over here, from input and output side, they are being taken out from the circuit, right? When they are being taken out from the circuit, so the point is we are going to have this circuit right over here, and I have made a simplified version that I'm providing VCC at the base as well as I'm providing VCC at the collector over here, right? Now, once we have this circuit, so we, from our previous knowledge, IE is equal to IB plus IC, as well as IC is equal to beta times IP, and we also know that VBE is equal to 0.7 volts, right? Now, once we look at the circuit, we can figure it out that where is the base current, where is the collector current, and where is the emitter current flowing in the circuit. With that, we can also see that the potential between the base and the emitter is VBE, and the potential between the collector and the emitter is going to be taken as VCE, right? Now from there, what we can see that there is the input side, right? And once there is an input side of the circuit, so we can say the input side will be this thing. So this will be our input side of the circuit. Are you with me? This will be the input side of the circuit, right?
Yes.
Yes, sir.
And when we look at the input side of the circuit, we can have the equation from here, which can be, if you see, VCC should be equal to the drop in the base resistance of the circuit plus the drop between the base and the emitter junction of the transistor, right? So when we look at this, so the equation can be written as, VCC what we can do, we can write VCC is equal to
सर स्क्रीन हैंग है सर
VCC
ये
is
सर नजर
equal
नहीं आ रहा
بداية قد يصير
Osakari,
ये सर अभी नजर आ गया
VCC is equal to IB RB plus VBE. Are you with me?
यस सर
Right?
नो सर
G.
No,
Again,
समझ नहीं आई. VCC is equal to IB.
if you
सर
see
ये
the,
समझा दे सर
if you see, I have encircled the input side of the circuit, and by encircling the input side of the circuit, what we can see that VCC is the potential which is being applied at the RB resistor. So VCC should be equal to the drop in the RB resistor plus the drop between the base emitter junction, right? Applying the Kirchhoff voltage law, right?
Yes.
So if you are unable to see what I am talking about, so this means you have not cleared the BEE subject very efficiently,
Yes, sir.
right?
मजा भी sir.
ठीक है जी.
Yes, sir.
So the equation which we are getting over here is by applying the KVL over here, applying KVL to this circuit. So if you see, we are going in this direction, right? When we are going in this direction, so VCC should be equal to the drop across the base resistor. And what is the current flowing in the base of the resistor is IB. So this means the drop over here will RB times IB, and then we have a drop between the base and the emitter junction. Drop between the base and the emitter junction is EBE. Therefore, the equation which we are getting over here is VCC is equal to IBRB plus VBE. Are you with me now?
Yes, sir.
And if we just manipulate this thing, what we can get is IB RB is equal to VCC minus VBE, right?
Yes.
Or what we can say that IB is equal to VCC minus VBE divided by RB. So we get this equation. Are you with me?
Yes, sir.
Yes, sir.
Okay, Ji. So this is the input side. Now, if we take a look of the output side of the same circuit, so the output side of the same circuit will be something, if I say, so this will be our output side of the circuit, right? Now, the output side, again applying KVL to the output side of this circuit, what we are going to get from here, that VCC again should be equal to the drop between the RC resistor plus the drop from collector emitter junction. The drop between the collector emitter junction is VCE, right? And this means what we can have, that for the output side we will have the equation that can be written as, for output side, applying KVL, we are going to get VCC is equal to ICRC plus the drop between the collector emitter junction, which is VCE, right?
Yes, sir.
And we also know this thing that IC is equal to beta times IB, right?
Yes, sir.
Yes, sir.
And we also know this thing that if we just play around with the equation, what we can get is VCE is equal to VCC minus ICRC, right?
Yes.
So this means that we can also see into the circuit, and the VCE indicates that it is basically the potential difference between the collector voltage and that of the emitter voltage. If you see, VCE is basically the difference between VC minus VE, right? Are you with me?
Yes.
सर इसकी समझ नहीं है सर, इसका क्या मतलब है?
Okay, if you see at the circuit, what we say that over here we are taking the VCE. VCE means it is the difference of the potential at, if I say it is something, right? So the potential at the collector is VC. The potential at the emitter is VE. So the difference between VC and that of VE will represent the voltage VCE, right?
Clear sir, clear.
So what I have written over here is VCE is equal to VC minus VE, right? But as you can see that in the circuit, the emitter is directly connected to ground. So when the emitter is directly connected to ground, so this means emitter at the voltage equal to 0, right? So this means VCE should be written, or it should be VCE should be equal to VC minus VE, because the emitter is directly connected to ground, so this is at 0 potential. So VCE is equal to the potential which we are getting at the collector of the circuit. Are you with me?
Yes, sir.
And similarly, if you see, we have a drop between the base and the emitter junction, right? So the drop between the base and the emitter junction, this can be, we can say, the potential at the base and the potential at the emitter, right? So the difference between the potential at the base minus the difference of the potential at the emitter will be taken as over here. So what we can write VBE is equal to VB minus VE over here, right? Again, the emitter is at the 0 potential, so what we can say, VBE is straight away can be written as VB over here. Are you with me?
Yes.
Right? Now, what we can see that this circuit is, G, question? Any question? Is this thing fine? Is this thing fine?
Yes.
Okay.
Yes, sir.
Now, if you remember, this circuit is basically, as you can see, we have the input side as well as the output side. And if you see, emitter is common in between the input side as well as the output side, right? So this means this circuit is basically common emitter circuit, and with the name, which is the name of the circuit is fixed bias configuration common emitter circuit, right? Are you with me?
Yes, sir.
Because if you see, emitter is common in the input side as well as the output side. So this means the output characteristic curves will be the same as the output characteristic curves which we have seen in case of common emitter configuration circuit, right?
Yes, sir.
So for that, what we can see that for the output characteristic curves, we have basic. Okay, for the output characteristic curve, we have basically the circuit which is something, the output characteristic curves which we have seen from our previous circuits. It is in between the IC and that of VCE, right? IC is the output current and VCE is basically the output voltage for the common emitter configuration circuit. We will start in 5 minutes because it is now the 40 minutes limit. So we will start in 5 minutes. Okay, ji? We will start from there.
Yes, sir.
Yes, sir. Okay, sir. Thank you, sir.
Sir, zuko ema chini magenta break.
हाँ बच्चे